Okay guys, let's take a look at today's lesson. Today it's actually the last lesson in this unit on statistics. We're going to move into probability after this, but it's a good one. It's modeling data. We're going to look at the correlation coefficient R, and we're going to look at the least squares regression line. So these things we're going to learn how to do both ways, basically by hand and with a calculator. So the first we'll look at is correlation. The correlation coefficient R, it gives a measure of how well the model fits a set of data. And this range for R is -1 to 1. We are just going to be working with linear. We're not going to be working with quadratic or anything else, just linear. And so for the linear model, R being close to a +1 indicates that there's a strong positive linear correlation between the model and the points, between x and y basically. And R being close to -1 indicates a strong negative linear correlation between x and y. And if R is close to 0, that indicates either a weak or really no correlation whatsoever. This is the formula that we use to calculate R, and a programmer programmed that into our calculators, so we want to thank them, right, for programming this into our calculators. We're actually going to work it both ways. It's important that we know what it's doing and how it works, because we need future programmers to program this for us, right? We don't want to just say, oh, we don't know how to do that, let's just use a calculator. Well, what if all the calculators break? I mean, I don't know. We need to know how to do it so that somebody else can program it in for us. So all these we're going to talk about actually in least squares regression, but let's finish with our correlation. Here, if we were just looking at the scatter plots, and you have some problems on your daily work where you're looking at the scatter plots and you need to match the R value with them. So let's just talk about this. This one right here, it's positive, it's got a positive slope, and they're really tightly grouped together. So this would have a pretty strong correlation to whatever line that we were able to write for it. This one over here is negative. We see it's going negative, but see how the data points are dispersed a little bit more. They're not really tightly grouped in the middle like these are. This would probably be, less of a strong correlation than this one. Okay. So let's talk about least squares regression line. This is actually the exact formula that your calculator uses to regress the points into a line that I know you've used before. So what we're going to do is we're going to work it with 4 points, with 4 data points. We won't do any more than that. So we're going to use 4 data points, and we're going to complete this table. You do not need to memorize either of these formulas. They will be given to you. And I'm probably going to also give you this table just to help with organization. And plus, so it'll be easier for me to grade your work so I can see where it all is. I probably will give you this table. So what we do is we enter information from our 4 points into this table and come up with these numbers that we plug into this formula. So let's talk about the numbers. The N happens to be the number of points you're going to use, and we're going to use 4. So N would be 4 for us. Sum X is the sum that you get at the end of this column, sum X. Sum Y is the sum of the numbers in this column. And then another sum X. This is sum X squared. It's going to be the sum of the numbers in this column, and then sum XY is the sum of the numbers in this column. So that's why the chart is very helpful. It generates the numbers that we're going to need to plug into this template. This is a template for a system of equations that we will solve. Okay, and we will get the exact same number that your calculator is going to get, although ours is going to be in exact form. It's going to be a fraction, and the calculator is going to just yield a decimal. Okay. So let's jump into some examples on the next slide. Okay. So the first example we have, it says find the least squares regression line for the points. What that's really asking us is to use those 4 points and regress that data into a line. That's what we would have asked the calculator to do. And we'll, again, like I've said, we're going to do both. We're going to do with calculator and without calculator. So let's go ahead and copy our points into this chart. So we have -3, 0. We have -1, 1. we have 0, 2, and we have 2, 3. So those are our 4 data points. Now I'm going to add the columns because we're going to need those numbers in our formula. So I'm going to add this down to get sum x. So negative 3 minus 1 plus 2 is a negative 2. So I'm just circling it just so we can see that that is sum x. So the y's, I'm going to add those, the 3, the 2, and the 1, and we get a 6. That's what sum y is. It's a 6. Now in this column, we're required to multiply the x and the y numbers. So negative 3 times 0 is 0. Negative 1 times 1 is negative 1. 0 times 2 is 0. And 2 times 3 is 6. Okay, once we get those numbers, we need to add that column, and that gives us 5. So sum xy is 5. The last column wants us to take all the x's and square them. So we're going to square negative 3 and get 9. Square negative 1 and get 1. Square 0 and square 2 and get 4. And then we're going to add all those numbers up and get 14. So sum x squared is 14. Okay, we okay with that data? So now what I'm going to do is I'm going to take this data and I'm going to transfer it into this template right here. This is going to give me my system of equations that I'm going to have to solve. So for us, n is 4, so 4b plus sum x. I go look at my chart. I see sum x is a negative 2, a, and then sum y, here look at my chart and I get a 6. So there's my first equation for the system. Let's work on the second one. So sum x is a negative 2. Sum x squared is a 14. And sum xy is a 5. So here's the system of equations that I'm going to be required to solve. Now I want to caution you here, when the numbers are like that, integers, 1 or 2 digits, we're going to be, or even a fraction, we're going to be doing those by hand with the help of a calculator to do number crunching for us. I'm going to let you have a calculator to number crunch. But if they're gigantic numbers, like in the thousands, we're not going to do that by hand. We're going to be able to use a matrix. Do you remember how to do matrices? Solve system with matrices on your calculator? Iffy, so-so, yes, no? Okay. I will try to help me remember to show you that when we go back to do the calculator stuff. Okay? Alright, so but this one is just regular old numbers, so we're going to, I would solve by elimination. You can choose whatever technique you like. I would take this one and I would multiply it by 2. So that would give me negative 4b plus 28a equals 10. And then copy that first one down underneath. And then just add. So that gives me 26a is 16. So a is 16/26 or 8/13. So that's my a value. Okay. So now I'm going to take that, I'm going to sub it back in to get my other value, my b value. So we have 4b equals, 4b minus 2 times 8/13 equals 6. So 4b minus 18/13 equals, and 6/13 would be 78/13. So I'm going to add the 18/13 over, and that's going to give me, what, 94/13. And then I multiply by 1/4, and that gives me reduced 47/26. I did 2 goes into 94. Alright, so let's write our equation. The purpose of this is to get our equation of our line. The line is y equals ax plus b. That's the format of the line. And if you looked in your calculator, that's exactly what the format in your calculator looks like. It's got ax plus b. That's the one we're doing. So our a would be 8/13. So y equals 8/13 x. And then our b is 47/26. And this is our least squares regression line. Okay, so we were able to calculate that using the formula by hand. And in just a moment, we'll let the calculator calculate it, and you'll see it's the same thing. Okay? So now let's look at number 2, find the correlation coefficient of example 1. So we're going to use the data from example 1, and we're going to find the correlation coefficient. Really the only thing in this formula that we are missing up here, if you look, we have the sum, we have the n, we've got the sum xy, all that. This is the one that we're missing. We didn't calculate sum y squared because we didn't need it for the other one. We do need that for this one. So I'm just going to kind of come up here and do just a little piece right here. We'll just put the y squared right here. We'll calculate that. We'll need it for this other formula. So 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. I add all that up, and strangely, I get 14, which is the same as sum x squared. It doesn't normally end up like that. It just happened to. Okay. So let's start plugging into our formula. R equals. So n is 4. Sum xy is 5. Minus sum x is a -2. And sum y is a 6. All over. Okay. So our first radical is n, which is 4, times sum x squared, which is 14, minus sum x squared. And then the other radical is n, 4, times sum y squared, which is 14, minus sum y, which is 6 squared. Aren't you glad we don't have to memorize these formulas? Yes. So that, of course, the formula that's required for you to show. Now in the numerator, I'm just going to go ahead and multiply all that out. So 4 times 5, and then minus the -2 times 6. That's just going to give us 32. And the first radical, after I multiply and combine like terms and such, I get a 52. And the second radical, after I multiply, combine like terms, I get 20. Now I'm going to simplify this. Our number is going to be in exact form, so I'm going to simplify this. And I'm a big fan of the factor tree. I just like it. It's very helpful to somebody like myself who doesn't do big numbers well in my head, so the factor tree is very helpful. So this shows me that I'm going to have 32 over, I have a 2 from here and 2 from there, so 4 square root of 13 times 5. 13 times 5 is what, 65? And then 32 fourths gives me 8. So we have 8 over root 65. That's our R. R is 8 over root 65. Okay? So what we're going to do, if we weren't going to use the calculator, I mean we are going to use it just to, because there are some problems that we're going to do with the calculator and some problems you won't. This is approximately like 0.99227778. So that's a pretty strong correlation, isn't it? 0.99, that's a pretty strong correlation. And it's positive. So that's a strong positive linear correlation. All right. So let's go to the calculator. Are we okay with this? Everybody have what they need? 'Cause I'm going to need to erase. All right, let's go to the calculator, and we're going to work it from the calculator as well. Okay. So the first thing I'm going to do is I'm going to enter my x and y coordinates. We would go to stat, edit. So stat, edit. And you recall how to clear that column. So I'm going to put the points in. I'll put all my x coordinates in first. So -3, and then -1, and then 0, and then 2. And then my y coordinates are 0, 1, 2, and 3. And then the first thing I'm going to do is double check and make sure I have my points in correctly. So negative 3, 0, negative 1, 1, 0, 2, 2, 3. Okay, they're in correctly. Okay, so what we're going to do now is we're going to turn the diagnostics on. You may remember that from last year or not. There's probably more than one way to do it. I go through the catalog. So I would do blue and then there with the catalog. They're all in alpha order. So I would like to go to D for diagnostics. So I press this button for D. And then I just scroll down to diagnostics. Let's see. Diagnostics off. We want diagnostics on. There, diagnostics on. So we're going to hit enter. And then enter. Okay, so the diagnostics are on. So let's go through and go to Stat, Calc. So that's where all our regressions are. I'm sure you did some of that last year. We are focusing on number 4. Notice how it's in the same AX plus B like ours is. So we would go to 4. Yes, our X's are in list 1. Yes, our Y's are in list 2. If I wanted to store this, let's say I was going to use it to approximate some data, I would put my Y1 here. Let's recall how we do that. We would do alpha trace, and that gives us all of our Y's to choose from. Just for fun, let's just put it in Y1. And then we just calculate. So this is the decimal form of the problem that we did, this 0.61538. When you're doing this on the calculator for me in just a few minutes, you can, for your answer for the equation, you can go to the thousandths. You could round to the thousandths if you like, or more. You can use more decimal places if you want, but at least the thousandths. And then there's our correlation coefficient R. All right, so that's how we would do it on the calculator. Just to remind you about systems, let's go to the matrix. Doesn't that sound so fun? Go to the matrix. Let's go in the matrix. That's so fun. So names, let's go edit matrix A. So if I have a system that I'm going to solve, typically the one I would let you do a matrix for would be like gigantic in the thousands. I'm going to do a 2 by 3. That's what I would do. And I would type the numbers in. This now, in our formula that you would fill into, this first column is actually B. Did you notice that on the template? It's B. And this column is A. So that means that when you get your answer, it's going to be in reverse order from what you're used to. Right? It's going to be like the B is first and the A is second. We're used to it being alpha order, but this template is not in alpha order. So let's just type the one that we had in. So we had a 4 and then a negative 2 and then a 6 and then we had a negative 2 and then a 14 and then a 5. Now what I like doing is reduced row echelon form, RREF, instead of the inverse matrix thing. So I would just, so I have that in. We're going to get out of the matrix. And then yes, we're going back in the matrix. Sounds so fun. And then we're going to do a calculation. It's down at the bottom. It's this, RREF, reduced row echelon form. Okay, that one. And then we pull down the matrix A, because that's the one that we're using, and hit enter. So notice that it gives us the same numbers that we got the other way, using the calculator with the diagnostics on. But please note that this is not A, this is B. This one is B and this one is A. Just so that you know when you're copying them down on your paper that you don't get them reversed. Okay, so that's how I would do a matrix. I would use reduced row echelon form. There are other ways, but that would be my primary way. Okay, questions?